everybody. Yes.
We don't have an online quiz today, or we do? I don't remember if we usually have them for labs.
No, not
No.
for the lab. The lecture exam. After lecture
Okay.
exam, it is done.
Make sure.
So everybody, today we'll talk about the endocrine system. You know that two systems belong to the control system of the body, right? The nervous system and the endocrine system. So those two are very important systems among the 11 systems that you have in the body, right? So endocrine system consists of the glands. What kind of glands? Endocrine glands. Okay. Endocrine glands are located in different parts of your body. We'll see the important endocrine glands and their functions. First, there are two types of glands in your body. One is called the endocrine, another is the exocrine. So those are two types of glands. Okay, so endocrine glands and exocrine glands. Okay. Endocrine glands, like this is a gland. These are the cells that secrete the hormones. Okay. If you see inside the endocrine gland, what you will see the capillaries. Okay, so these are the blood capillaries, right? And what happens? These cells secrete the hormone in the interstitial space, interstitial fluid here. That means in between the cells, outside of the cell. Okay? And then from there, the hormone molecules enter into the blood capillary. Okay? Enter into the capillary blood. And the blood then takes the hormone molecules out from the gland. Okay? So that's how the endocrine secretion occurs. Okay? So the cells first secrete the hormone molecules in the interstitial fluid. Then from there, the molecules enter into the capillary blood. Then blood takes it out from the gland. Is it clear? Blood takes it out from the gland. Now, you tell me, once the hormone molecules or hormone enters into the blood circulates throughout the body, right? Blood circulates throughout the body. So the hormone can be taken far away, right? From the gland. Make sense? Because blood goes everywhere. So the hormone can act far away from the gland. Okay? And the action is more generalized because blood goes everywhere, right? So it can work on more than one tissue, more than one target organs. Is it clear? So that is the endocrine. In case of exocrine, this is the exocrine gland, and these are the cells that secrete the hormone, and inside the exocrine gland you have tube-like structures. Those are called the ducts, ducts, tubes. So these are the ducts. And these cells directly secrete the chemical into the tube or duct. Okay? So, duct, and from the cell, the chemical is directly going into the duct. Small ducts join to form larger duct, and then the duct or tube gets out from the gland and releases the chemicals just outside of the gland. Since it is not going to the blood, it acts locally, just outside of the gland. Okay? So, in case of exocrine, the chemicals are secreted directly into the ducts inside the gland. Ducts are what kind of structures? Tube-like structures, right? Like tubes. And small tubes join to form the larger, bigger tube, and that gets large duct gets out from the gland. Okay? So the chemicals will be released just around the gland. Make sense? Because it's not going to the blood. So that is the exocrine. Example of endocrine: thyroid, pituitary. I'll just give you a couple of examples. Adrenal gland. Okay. Example of exocrine glands: glands of your skin, glands of the skin. You know, skin has sweat glands, sebaceous gland, right? So those are exocrine type glands. Okay. Now, if I ask you in your exam that write down few differences between endocrine and exocrine glands. First thing you will say that in case of endocrine, hormone molecules are first secreted into where? Between the cells. Interstitial space, interstitial fluid, right? Then from there enters into the capillary blood. Make sense? So that is number one. In case of exocrine, the chemicals are directly secreted into the duct. Is it clear? So that is number one. How they are secreted, right? In case of endocrine, first into the fluid, interstitial fluid in between the cells. From there enters into the capillary blood. Okay. In case of exocrine, directly into the duct, tubes. Okay. Number two difference. Since in case of endocrine, the molecules are entering into the blood, blood can take it far away from the gland. Is it clear? So the target could be far. In case of exocrine, the target is just outside of the gland, because tube just ends the outside of the gland. Okay, so local. This is more widespread action. Okay, generalized. We say more generalized. That means widespread. This is more what? Localized. In this case, the target could be far from the gland. Makes sense, right? Like pituitary in your brain, right? That hormone, pituitary hormone, can work on the kidney. Blood will take from here to there. Makes sense? So the action is what? Near. Near means what? Just outside of the gland. Outside of the gland. Okay? And you will say in this case interstitial fluid, and from there the molecules enter into the blood. Okay? So those are few important differences between endocrine and exocrine. Okay? Now, since we are going to talk about the endocrine system, we'll see the important endocrine glands, their locations. If we start from the brain, in the brain you have the pituitary gland, right, and pineal gland. Those two are important glands in the brain. Then if you go further down, in front of the lower part of the neck here, you have which gland? Thyroid. Thyroid here, okay? And behind the thyroid, if this is the thyroid, in the back of the thyroid, you have tiny parathyroid glands, okay? Then, if you go further down, you have the pancreas here, like this. Pancreas is not purely endocrine. It is a mixed type gland. Why? Because inside the pancreas, you will see both endocrine and exocrine, okay? So, pancreas is a mixed type gland, okay? We'll talk about that. Then, on the top of the kidneys, you have adrenal glands, also called suprarenal glands, right? Suprarenal, above the kidney, like the cap of the kidney. And then you have gonads. Male gonads are testes, female gonads are what? Ovaries. Okay? So 2 testes and how many ovaries? 2 ovaries. Okay? Yes.
Thallus is also included.
Second?
Thallus. The thallus.
Thymus. Thymus is another gland. It's not listed here. Yes, thymus is also endocrine. And in some places you will see hypothalamus. You know hypothalamus? This is also considered as endocrine. So you can write down these 2, endocrine. So hypothalamus in the brain and thymus is in the upper part of the chest, thorax here. Okay? So those are also important endocrine glands. So write down those 2. Now, here you see thymus, the upper part of the chest. Now, you know that pituitary gland is called what? Master gland. Remember that? Pituitary is the master gland. Why? Because pituitary gland controls the other endocrine glands of your body. Okay? But pituitary has a boss too. Although pituitary is the master, but master has a master too. Okay? Who is that? Hypothalamus. Okay? So, hypothalamus is very important, right? It controls the pituitary. So, if this is hypothalamus, you know thalamus, under the thalamus you have seen the hypothalamus, and this is the pituitary. Okay? So, this is hypothalamus, and this is what? Pituitary. Now, pituitary has 2 lobes. This is one, this is another. Okay? If this is front, this is called the anterior lobe, and this is the back, called what? Posterior lobe. So 2 lobes in the pituitary. Okay? Anterior lobe has another name, that is called adenohypophysis. Anybody remember hypophysis, hypophyseal fossa on the sphenoid bone? You remember that? At that time I told you hypophysis is another name of the pituitary gland. Okay? So, anterior lobe of pituitary is called adenohypophysis. Remember AA. Okay? Posterior pituitary has another name, that is called neurohypophysis. Neuro, M-E. Okay? Neurohypophysis. Because in this part the cells are like neurons. That's why called neurohypophysis. Okay? Neuron-like cells. And in this part, the cells are more like gland type cells, glandular cells. Adeno means gland, you know. Adeno means gland. So these cells are more like gland type cells, that's why called adeno. These cells are more like neuron type cells, that's why called neuro. Hypophysis is pituitary. Okay. Now, the anterior pituitary releases 6 hormones, and posterior pituitary releases 2 hormones. Okay, you need to know those names. Okay, from anterior pituitary, how many? 6. From posterior pituitary, only 2. And these hormones control the other glands, secretion of other glands. Okay, so that's the pituitary gland. Now, I told you hypothalamus controls the pituitary, right? It's the boss of the boss. So, how hypothalamus controls the anterior and posterior pituitary? You need to know that. Okay? So, in the hypothalamus, you have the neurons. So, long axon of these neurons go to, this is anterior, right? So, let me draw this way. So, these are the neurons in the hypothalamus, and long axon of these neurons go to the posterior pituitary. You know the axons, axon terminals, like this. Okay, go to the posterior pituitary, and these axons bundle together, and that is called a tract. You know what is a tract? So this is called, see, this name is easy all the long. Hypothalamo-hypophyseal tract. Tract is the bundle of fibers, right? Going from hypothalamus to hypophysis, pituitary. That's why it is called what? Hypothalamo-hypophyseal tract. Hypothalamo-hypophyseal tract is the bundle of axon, you know that. So that is how the hypothalamus talks to the posterior pituitary. What happens when hypothalamus sends signal to the posterior pituitary from the axon terminal? Chemicals are released from the axon terminal. Okay, here, and these 2 chemicals are stored here in the posterior pituitary. Okay, we'll know the name of those 2 later. Just know that from the axon terminal, those 2 chemicals are released here. Okay. Now we'll see how the hypothalamus talks to the anterior pituitary. Okay. Differently, it talks to the anterior pituitary. What happens? You have blood capillaries here, you know, capillary bed. So this is one capillary bed. And this is a blood vessel. And here you have another capillary bed. Okay? So these are capillaries. And this is the blood vessel connecting 2 capillary beds. One capillary bed is in the hypothalamus, another capillary bed is in the anterior pituitary. Okay? So these 2 are capillary beds connected by this blood vessel, and this is called portal vessel, portal system. In your body, sometime you will see that 2 capillary beds are connected by a blood vessel. This is one of those. Okay, you have other areas where 2 capillary beds are connected by a blood vessel, and in that case, when two capillary beds are connected by a blood vessel, that is called portal vessel. Okay? So this is one example where you have the portal vessel. So what happens here, you see, these neurons secrete the chemicals into the capillaries here, and the blood brings those signal molecules or hormones here and releases here. Okay? So that's how the hypothalamus talks to the anterior pituitary through the portal vessel. Hypothalamus talks to the posterior pituitary through the bundle of fibers, axons, tract. Okay? Okay. So when hypothalamus sends signal to the anterior, signal goes through the blood. When hypothalamus sends signal to the posterior pituitary, signal goes through the axons. Okay? Is it clear? Make sense? Got it? Okay, so differently, right? Now, types of hormones. The hormones, the endocrine hormones, could be two different types. One is called amino acid based hormones, like amines, peptides, and another is steroid. Steroid hormones mainly come from the cholesterol, fat or lipid. Okay? So steroid hormones are cholesterol or lipid based hormones. Amino acid hormones are protein type hormones. Make sense? Because we know that protein molecules are formed by amino acids. Amino acids join together form the protein molecules. Chain. We have talked about that here. So some hormones are protein in nature or amino acid in nature. Some hormones are steroid or lipid or fat in nature. Example, thyroid hormone is a amino acid based hormone. Okay? Your adrenal gland releases the hormone. That hormone is called cortisol. Another is sex hormones. These are steroid type hormones. Steroid hormones. Estrogen, progesterone, testosterone, okay? And cortisol comes from the adrenal gland. These are steroid hormones, okay? Most of the hormones are amino acid based hormones. Okay, now what are those 6 anterior pituitary hormones and 2 posterior pituitary hormones? Okay, you need to remember these names. 6 anterior pituitary hormones are growth hormone or GH, thyroid stimulating hormone or TSH, okay, adrenocorticotropic hormone ACTH, follicle stimulating hormone FSH, luteinizing hormone or LH, and prolactin PRO. Those are 6 anterior pituitary. Now, just think the name growth hormone. Okay, its name is telling you its main function. So growth hormone helps in the growth of the body, right? Growth hormone works almost everywhere on all tissues of your body and helps to grow the organs of the body, parts of the body. But in 2 types of tissues, the action is more. The growth hormone works more on 2 types of organs or tissues, skeletal muscles and the bones. Is it clear? And you know those 2 things mainly help to grow the body, right? But it works on other organs too. Okay. thyroid stimulating hormone. Its name is telling you, right? This hormone will go where? To which gland? Thyroid gland, right? And will do what? Inhibit or stimulate? Stimulate. Its name is telling you, right? Thyroid stimulating hormone. So from the pituitary, it will go where? Here. You have the thyroid gland, right? And will stimulate the thyroid gland, or will tell the thyroid gland to release more thyroid hormones. Okay? Release the thyroid hormones. Adrenocorticotropic hormone. Now you tell me. This one will work on which glands? Adrenal glands. Its name is telling you, right? Adrenal. Adrenal glands are located on the top of the kidneys. So, from pituitary, this hormone will go to the adrenal glands. Is it clear? Now, adrenal gland has two parts. Probably I talked about this in my first lecture. This is the kidney. This is the adrenal gland. If you cut the adrenal gland, you will see it has outer part is called the cortex, and inner part is called the medulla. Okay. Now ACTH will work on which part? What do you think? Cortex, because its name is adrenocorticotropic. Cortical part, right? Cortex. So this hormone stimulates the adrenal cortex. That means the outer part of the adrenal gland. Okay? Good. Follicle stimulating hormone and luteinizing hormone. Just write down these two hormones work on the gonads. Work on what? Gonads. Testes, ovaries. Okay? And these two specially help in ovarian cycle. Help in what? The function of the ovarian cycle, and ovulation. Also write down, help in ovarian cycle and ovulation. Okay? So action is more in female gonads, because inside the ovary, the cycle, right? Ovarian cycle occurs. Ovulation, the release of egg, right? Those are helped by these two hormones. In male, works on testosterone, works on testes, and help in sperm formation. Prolactin, the last one. Prolactin works on female breast and help to produce what? Milk. So prolactin is released more when? After pregnancy, right? Like after birth, right? The infant needs mother's milk, right? So plenty of prolactin is released after birth, right? So production of milk. So those are 6 anterior pituitary hormones. Now let's see the posterior pituitary. Posterior pituitary releases 2. One is called, both are very important. One is called oxytocin. And another is called ADH, antidiuretic hormone. Okay? So these two are posterior pituitary hormone. Posterior pituitary hormone. Now I'll mention the important functions of these two. Okay? Oxytocin, number 1. Very important. Oxytocin helps in the contraction of the uterus. Uterine contraction. That helps in what? Birth, childbirth, right? So, very important. Oxytocin causes uterine contraction to help in the childbirth, okay, labor. Number 2 function of oxytocin. I told you prolactin does what? Anybody? Production of milk. Oxytocin helps in ejection of milk, help the milk to come out. Okay, so oxytocin helps in what? Ejection of milk by contracting the mammary gland. Okay, so those two important functions of oxytocin, if I ask you, we will mention childbirth and ejection of milk. Antidiuretic hormone or ADH. Have you heard the word diuretics? In newspaper or magazine you will read very often. Diuretics. Diuretics do what? Produce more? Diuretics produce more what? Urine. Remember, diuretics produce more urine. Is it clear? Coffee is one type of diuretic. If you take too much coffee, more urine is produced. Is it clear? So natural diuretics, but also we have medicines, right? That will cause production of urine, like Lasix. Anyway, so the word, this is a common word, general people read in the newspaper or magazine. Diuretics cause what? More urine production. Is it clear? So now you tell me, antidiuretics will do what? Produce more or less? Less. Okay. So this hormone is called an antidiuretic hormone. So it produces less urine. Is it clear? Okay. So if ADH is released more from the posterior pituitary, amount of urine will be more or less? Less. Is it clear? So antidiuretic hormone reduces the production of urine. Now you tell me, if I block the ADH production, then what will happen? The person will produce more urine, plenty of urine, right? Will frequently go to the bathroom, right? Because more urine will be produced, right? And that can happen. That happens.
People with diabetes?
No, this is not the common type of diabetes that we relate with insulin or or sugar. This is not related to sugar, right? You understand? This is not related to sugar. This is due to lack of what? Antidiuretic hormone. Sometimes we see that posterior pituitary tumor can destroy the cells here, right? Destroy the posterior pituitary. So ADH secretion will be less. So the person produces plenty of urine. Body fluid losses body fluid, right? So loss of plenty of body fluid, dehydration will occur quickly. And this is called diabetes insipidus. This is not related to insulin or sugar. This type of diabetes is called what? Diabetes insipidus. Insipidus. Okay? Not mellitus. Diabetes mellitus is the diabetes that is related to insulin and sugar. Okay? Okay. Now, let's talk a little bit about the growth hormone. I told you that growth hormone works everywhere, right? And helps in the growth of the tissue or organ. But action is more on which two organs? Bones and the skeletal muscles, right? So, if during the growth of the body, that means during the early part of your life, growth hormone secretion is more than normal, the person's body will grow fast, right? So the person will get very big, right? And that is called gigantism or giantism. Gigantism or giantism due to excess secretion of what? Growth hormone. During when? During the growth of the body. You know ossification, right? once the growth is completed, the bone growth is completed, ossification is completed, then if growth hormone secretion occurs, the person will not grow anymore because bone is already, growth has been completed. Is it clear? So, if during the growth of the body, that means early part of your life, growth hormone secretion is more, that will cause gigantism or giantism. Make sense? The person will grow much bigger than average people, right? Not only the bones and skeletal muscles. I told you growth hormone works on other organs too, right? So the person's heart will be what? Bigger. Make sense? Other organs will be larger. Enlarged liver and other organs. Make sense? Is that good or bad? Big organ doesn't mean good, okay? Normal size is good. Small is not good, big is not good. So if the heart is big, right, liver is big, the they will not function properly, okay? And also the growth hormone causes the metabolism of carbohydrate. And carbohydrate metabolism will produce a lot of sugar, glucose in the body. So all the time you will see in giantism patient, they have high blood sugar. Make sense? Because of more metabolism of carbohydrate. Is it clear? So few things. The person will be big, right? Organs will be larger, may not function properly, and the sugar will be, in the blood will be always high, okay? And if the sugar in your blood is always high, your pancreas is working more, right? Releasing more insulin all the time to reduce the sugar. Insulin reduces the sugar. So at one point, the pancreas will burn out the cells. Because of too much function, the cells will burn out. Make sense? That will cause what? Diabetes. If pancreas cannot produce any more insulin, person eventually will get what? Diabetes. And that's why you see almost all giantism patient or giant person suffer from what? Diabetes mellitus. Diabetes mellitus, okay? And the lifespan will be what? Long or short? Short, because diabetes and other complications because of enlarged organs. So that will cause the lifespan shorter than average people. Okay? So that is a problem. Now, your growth hormone secretion, normal amount of growth hormone secretion is very important. Now you understand, right, for the normal growth of the body, right? If the growth hormone secretion during the growth of the body is less than normal, then the person will not grow adequately, will not grow normally, right? So that will cause what? Dwarfism. So opposite of gigantism is what? Dwarfism. Due to lack of growth hormone secretion during the growth of the body. Okay? Once your growth is completed, if growth hormone secretion is less, it doesn't matter because your body has already grown enough, right? Growth is completed. Now, after the growth of the body is completed, if the growth hormone secretion increases during normal growth, during the growth of the body, it was normal, so your body size is normal. Make sense? Now, after your body growth is completed, if the pituitary, anterior pituitary releases more growth hormone after puberty, the person's bone, all bones are already developed, right? Formed. Ossification completed. So, what will happen in that case? Certain bones will grow not in length anymore, but in weight. Make sense? Will get thicker. Particularly, you will see which bones? The facial bones, mandible, and all other facial bones will get what? Thick. okay? Finger bones, phalanges will get thick. So you'll be able to see by looking at the face, okay? The face is bigger, mandible is protruded, okay? And the fingers are thicker fingers, okay? So those are the signs of the acromegaly. If the growth hormone secretion is more than normal after the growth is completed, those things will happen, okay? Also, the tongue gets thick, skeletal muscle of the tongue, okay, gets thick. So the person, when the person will talk, you will see sluggishness, okay, slow. The talk is, not clear. Person's speech is not clear. Okay, so all those are the signs of acromegaly. You see this person. And this is a giant person, okay? This is normal size. Okay? So you see how big this person is. This picture is very famous. This person was from East St. Louis. Okay? And when, like 30 years ago, I read the textbook, we had this picture. So this is a very famous picture used to everywhere in the world. Okay? So, and this person is not too far from here. He passed away. So, okay. So that's the growth hormone. Now, the endocrine secretion is regulated by negative feedback mechanism. What is that? You see, I told you that pituitary hormones control the glands. For example, thyroid stimulating hormone, TSH, works on the thyroid gland. So this is the thyroid gland, okay? So hypothalamus sends signal to the anterior pituitary. Anterior pituitary releases thyroid stimulating hormone. Thyroid stimulating hormone is taken by the blood to the thyroid gland, and then thyroid gland will release thyroid hormones. For example, thyroxine. Or let me write thyroid hormones. Okay? So that's how the endocrine system works. You already know. Hypothalamus is the boss of the boss. So hypothalamus sends signal to the boss, pituitary gland, master gland. Pituitary gland releases the hormone that will go to the gland and will stimulate the gland to release the hormone from this gland. Now, when thyroid gland releases the thyroid hormones in the blood, the hormone level goes up. Okay, so hormones in the blood goes up. Okay, and when it reaches to a certain limit or level, then inhibition will go to the hypothalamus and the pituitary. Negative feedback. Negative feedback. That means inhibitory signal. That blood will tell that I have enough hormone, now stop secretion. So hypothalamus will not send signal to the pituitary. Pituitary will not send signal to the thyroid gland. So thyroid secretion will be stopped. Okay? So that is called the negative feedback mechanism. Okay? So that's how the endocrine secretion is regulated or controlled. Okay? I will stop here today since you had a also something else you have to do today since we are not having, we will meet on Thursday to finish the endocrine, okay? But I will give you a review, not review, what is that called? Evaluation, okay? Teaching evaluation. So you finish that, then you leave, okay? Another thing, tomorrow, everybody, tomorrow, although we are not meeting tomorrow, listen carefully, tomorrow we will do a bone marrow donor list. Now, before bone marrow donation was very complicated, right? The donor, we used to use the invasive method, right? Like, get the bone marrow directly from the bone. Now, if you want to donate bone marrow, they will take your blood, okay, it's like blood donation, and will get the stem cell from the blood. They don't, go inside the bone. So very simple, very easy, right? You will give your blood, they will suck the stem cells from the blood and will use them, okay? So tomorrow, our science club and amnesty club, they will do the bone marrow drive donation. So it's very simple. They will give you an envelope and you will collect the cheek swab, in cotton, piece of cotton, just give your cheek swab and put in the packed envelope and send it. Okay? So, make sense? And if they need your blood, they will contact you. There should be a form there.